All right, part 2 of chapter 1.6 is about horizontal asymptotes. So the thing we're going to be able to write now is what's the limit as x goes to infinity of f of x. We used to say like x goes to 0 or x goes to a, where a is some finite number. So this idea right here is our new skill that we're going to be learning, our new concept. What happens as time goes to infinity, for example. I'm going to start us with 3 interesting examples that have some interesting similarities and differences. One is 1 minus e to the minus x. The next one is square root of x. And the next one is log x. So go ahead and sketch each of those. This one might be a little hard. It's good to think of it in pieces. What does e to the negative x look like? It looks like this. What does negative e to the negative x look like? It looks like that, but flipped upside down. And then when you add 1 to it, negative e to the negative x plus 1, which is another way of writing this, it shifts the whole curve up. So it does something like that, shifts it up by 1. So to draw a more zoomed in version, goes through the origin, and it's extremely more and more curved over this way. What can we say about how that's behaving? Let's come back to that later. Let's draw a sketch of square root of x. It's like a parabola but sideways, right? And how about a sketch of log x? We know from our vertical asymptote work that it has a vertical asymptote at 0, and then we see it doing this, and we got to think about what's going on over there. So which of these functions is bounded above? Which of these functions can I put a horizontal line above and the function will never go beyond that line? Think about each of these. Can I put a horizontal line and never see this curve go above that line? Well, if e to the negative x is never negative, right? So I'll never be subtracting a negative. The smallest this could ever be is right near 0, and I would always be slightly less than 1. So at the horizontal line y equals 1, it will never get above that. So this is bounded above by the line y equals 1. Is square root bounded above? Is there any horizontal line you can put that the square root function will never exceed? Well, let's be a little silly. How about a billion? Can we say that the square root function will never get larger than a billion? So I'm going to put 1 billion with a question mark here. Is there any x value whose square root is larger than a billion? Well, so we're asking, does this ever intersect? Is there anything I can start with that when I take the square root, I get a billion? Well, sure. How about 1 billion squared? Take the square root of that, you get a billion. You go any farther, you're going to be above a billion. So any level you try to put on this, that value is, you're going to exceed it eventually. So this is not bounded above. I mean, you'd have to zoom out for quite a while to find this if you didn't have the power of algebra, right? How about log x? We're not worried about the vertical asymptote here, but let's think about what's going on here. Is there any horizontal line you can put and say log will never go above this? Well, we had fun with a billion before. Let's try that again. If I put a billion there, how can I ever get log to exceed that? Turns out I can. If I just do e to the 1 billion, then the log of that is 1 billion, and I've hit that point, and then if I go any farther to the right, I'm above that point, so this is also not bounded above. Which of these would you say keep growing forever? Well, these two clearly, right? Any value you try to put on it, it's eventually going to hit it. It could only hit that if it grows forever. But here, what do you think? It'll never get beyond 1, but it's never decreasing and it never perfectly levels off. So we could say all three of these grow forever. It's just these two grow fast enough that they exceed any bound eventually. What can we say in terms of limits here? What would you say about this one? The limit as x goes to infinity, 1 minus e to the minus x. What is that getting closer to? Is always getting closer to y equals 1, right? If you want it within 1/1 trillionth, you could find some x cutoff that after that cutoff, it would be within 1/1 trillionth. So we can say that this limit is 1, y equals 1. How about this one? X going to infinity of root x. Well, I can't say it's any particular cutoff, so it must be infinity. And then the same thing here. And these infinities still count as dne. So sometimes when we take a limit as x goes to infinity, we get infinity for the y values. Sometimes when we take a limit as x goes to infinity, we get some finite number. And next we'll think more about horizontal asymptotes. What would you say is a horizontal asymptote here? Does that look like a horizontal asymptote? Yeah, but these don't have them, right? So this one, we could say it has a horizontal asymptote at y equals 1, at least as we're going to positive infinity. Going to negative infinity, that curve just dives toward negative infinity. Whereas these don't have horizontal asymptotes. So next we'll think about an interesting question about horizontal asymptotes.